Do you know about time? You might answer that you can tell by looking at your watch. But is that really knowing time? How would you feel if you were told that there is no such thing as time? Let's start with a general discussion of time. In ancient times, people tried to determine time by looking at the movement of the sun and moon. In modern times, the time we are dealing with has its own units. First of all, what kind of time is a day? The clue is the sun. A day consists of morning, noon, and night. When the sun rises, sets, and rises again, a day, or 24 hours, has passed. This is related to the phenomenon of the Earth's rotation. One rotation of the Earth over a 24-hour period equals 1 day. So what is the time in 1 month? The clue is the moon. The moon orbits the Earth. Since the Earth itself also rotates, the shape of the moon, as seen from the Earth, changes over time. To put it simply, it takes 1 month from one full moon to the next full moon. Generally, the length of the month is around 30 days. But the length of the month on the calendar is defined based on the cycle of the phases of the moon. In many cultures that use solar calendars or calendar systems that take into account the phases of the moon, a month is about 29.5 days, about 29 and a half days, and is based on the cycle from new moon to new moon. In the modern Gregorian calendar, the year is generally composed of 12 months, with each month having a different number of days. The length of a month varies from 28 to 31 days, and the length of a year is generally based on the number of days in the year, with the longest month having the most days in the year. So what is the passage of time for a year? It is defined based on natural phenomena. In a day, the Earth on which we live rotates regularly around the sun. When the Earth completes exactly 1 revolution around the sun, a year has passed. This year consists of 12 months, usually 365 days, 366 days in leap years. A solar year, the time it takes for the Earth to complete 1 revolution around the sun, is approximately 365.24 days. But in a calendar that divides the year into 365 days, it is necessary to adjust the time to this decimal point. Therefore, this adjustment is made by adding a day every 4 years. This additional day is February 29, and this year is called a leap year. Why February? The addition of February 29 in a leap year has to do with historical background and cultural factors. In the ancient Roman calendar, the first form of the calendar had only 10 months and not enough days to include the winter season. So an additional winter month was established. Later, the Roman Emperor Julius Caesar introduced the Julian calendar in 45 BC, which established the concept of leap years. This calendar introduced a leap year every 4 years and adjusted for leap years by adding a day in February. Later, this practice spread under the influence of Christianity, and the addition of a day in February, which includes the church holiday of St. Valentine's Day, became established. This is the traditional reason for adding a day in February in leap years. Furthermore, February has fewer days than other months, and adding a day in a leap year has less impact on other months, making it relatively easy to adjust the calendar. That is why the additional day in a leap year was set on February 29. Time was further subdivided into smaller units based on 24 hours. Now the question, how many minutes are in an hour? The correct answer is 60 minutes, because 60 has many divisors. Fractions with 60 in the denominator can be expressed as whole numbers, making calculations easier. Furthermore, from an astronomical perspective, ancient civilizations used the movement of the sun and stars to measure time. Since the celestial sphere was thought to be divided into 360 degrees, and that 1 degree could be further divided into 60 minutes, the unit of time was also set to 60 minutes. Incidentally, 1 minute consists of 60 seconds. In general, time that has already passed is defined as the past, this moment, in which we are living is the present. This present will soon become the past, and the time to come is the future. Next, I would like to introduce some episodes from the great men of the past. It is said that the first human being to address the question of what time is was the ancient Greek philosopher Aristotle. Aristotle believed that time can only be perceived when motion or change occurs. For example, if you light a candle, you can recognize time because the wax melts with the passage of time. But if you don't light a candle, you cannot recognize that time has passed. Therefore, Aristotle solved that time is something that can be recognized when movement or change occurs, but not when it does not. In other words, if there is no more change in the world, there will be no more time. This means that the existence of time is dependent on change. The existence of time depends on change. Isaac Newton proposed a new theory for this concept. Newton proposed a new concept of time called absolute time. Newton's concept of absolute time, in contrast to the general concept of time, was that time ticked along at a constant tempo, regardless of the presence or absence of an object or the presence or absence of motion. Time is the ticking of time at a constant tempo, regardless of the existence or non-existence of objects or motion. Time is absolute, and time does not depend on anything, and nothing can stop the flow of time. This idea is so consistent with the nature of time as we experience it every day that most people take it for granted that this idea is correct. This is because the existence of time, contrary to Aristotle's view that the existence of time depends on change. However, it was Einstein who proposed a new theory for the concept of time. For those of us who believe in physics, the past, present, and future are merely illusions. Einstein argued that time does not exist. We use the concept of time in every corner of our lives and always feel the passage of time. How did he come to the conclusion that time does not exist? Einstein discovered the principle of the invariance of high velocity. From the point of view of a human being in any state of motion, the speed of light will forever remain at about 300,000 kilometers per second. Suppose, for example, that there is a spaceship that can travel at 90 of high speed, or 270,000 kilometers per second. The spacecraft and the light are simultaneously launched into the sky in the same direction, and a person observing the spacecraft and the light from the ground would see something like the following. At first, the spaceship and the light are running almost side by side, but after a while, the light gradually opens up the distance between the spaceship and the light. On the other hand, the person on the spaceship will see a completely different scene. On the other hand, the person in the spaceship will see a very different sight. From the point of view of the person inside the spaceship, the light should be moving a little bit faster alongside the spaceship. The light that is supposed to be moving a little bit faster next to the spaceship instantly pulls away from the spaceship and leaves it. So why is it that the person on the ground and the person in the spaceship are observing the same process? The reason is that people on the ground and people on the spaceship are observing the same process, but the observed results are different. The reason is that time moves at different speeds for people on the ground and people in the spaceship. The faster something is moving, the slower time flows. Therefore, a person in a spaceship moving at 90 of the speed of time than those on the ground. Thus, from the perspective of the spaceship at that time, light leaves in an instant. Einstein further discovered that the speed at which time flows is also affected by mass. Einstein discovered that the rate at which time flows is also affected by mass. The greater the mass, the slower time flows. The reason for this is that the greater the mass, the more it distorts the surrounding space-time. If a person were able to enter a black hole while still conscious, the black hole would have such a tremendous mass that people on Earth could be tens of thousands of years ahead of us after spending just 5 minutes inside the black hole. But at the speed that people like us travel, the time dilation and contraction is too small, and the change in gravity is too small for us to notice. We are too small to notice it. The concept of the present is a natural part of our lives. We take the concept of the present for granted in our lives, but the present that is essential to our lives does not really exist. For example, let's say that on January 1, you are watching a live webcast on your computer, and that, strictly speaking, you are in a state of present tense. The light emitted from your monitor takes a fraction of a second to reach your eyes. If that time is 1/billionth of a second, then what you are seeing is not the current streaming image, but the one that was streamed 1/billionth of a second ago. But the image you are seeing is not the current image, but the image that was delivered 1/billionth of a second ago. However, such a short time is completely negligible in our daily life, so what you see is not the current streaming image. However, the computer is 10 light years away, and the image is not the same as the one you are seeing now. But what if the computer is on a planet 10 light years away, and on January 1, you look at the location of the computer through a super telescope that can see 10 light years away, and what you see is not the streaming image you wanted to see. The reason is that it takes a long time for light to reach the Earth from that star. So what you see in the telescope is an image from a long time ago. So I decided to look at the transmitted image that I wanted to see at that time. And since the star is 10 light years away, I decided to look at the transmitted image. If you look at the computer through the telescope again on January 1, exactly 10 years from now, you will be able to see the image you wanted to see. If I look at the computer again with the telescope on January 1 exactly 10 years from now, will I be able to see the image I wanted to see? In fact, you will see a completely different image. And if you check the date on the computer, you will see the same image as before. The date displayed on the computer is not the date of January 1, 10 years ago, but a different date. The reason for this is that time moves at different speeds depending on the speed and mass of things. The velocity of the star on which the computer is located is different from that of the Earth, as is the mass of the star itself and the degree of space-time distortion caused by conservative celestial bodies. As a result, time on Earth is different from time on Earth by 10 years. As a result, time may have passed 10 years on Earth, but only 7 years on that planet. For example, suppose there is a man on Earth and an alien on a star 10 light years away. Since the rate at which time flows depends on the speed of motion and mass of an object. If the alien starts traveling in a spaceship, the alien's time slows down, and he is no longer in the same present as the man on Earth. In other words, the two will have different present times. This means that each thing in the universe has a different present. This means that the present is not an objective entity, but only a concept created by human senses. This means that the present is not an objective entity, but only a concept created by human senses. Time cannot be reversed, just as a broken plate cannot be restored to its original state. This is called an irreversible process, and the existence of this irreversible process makes us feel that time is a one-way passage from the past to the future, which is one of the properties of time as we think of it. This is one of the properties of time that we consider